Yes, Memuna, am I audible?
Yes, ma'am.
Okay, so we were doing this question and I had to run away. So let us just complete this question. How was your exam? I couldn't take the class of EMI also.
Yes, ma'am. It was not bad actually. The derivations was easy, but the numericals was difficult.
Okay, so I hope you got the information about the class that it wasn't there. Right. I hope you were not waiting on Friday. Actually, when I was taking the class, my grandmother was sick, so she
Okay.
passed away that time. So that's why I had to just leave the class in between, and that's why I couldn't arrange the class on Friday as well. Okay,
Yes.
otherwise I would have arranged it.
Okay, ma'am.
So yeah, and I couldn't inform the team to arrange any other teacher for you also because of everything.
Yeah.
So I hope the test was fine.
It was fine, ma'am. It was fine.
Please share the question paper with me.
Yeah. Okay.
Okay. Just share the question. Send it on the Learnivio's number. Just a second.
Okay. Right now?
Yeah, right now. Did you share, Memuna?
Yes, ma'am.
Okay, then I think they'll forward it to me. I'll just text them also to share it. Let me text them. They'll share it themselves. Okay, I think let's just start with the class. Already everything is getting delayed. So, in your school, which chapter is started? Can you tell me?
Wave optics.
Right now, are the exams going on? Wave optics.
No, no, ma'am. Yeah.
Okay, so that was just the physics test which had to be done.
Yeah. Only the UT3. Now we have pre-boards directly in December.
Okay, then. So in pre-boards, everything will come.
Yeah, pre-boards, everything will come.
Okay. All right, let us complete this. Let us complete EMI. And I think, do you people have any class after this?
No.
Not today. No. Then what we can do, because to cover up the syllabus, because syllabus is also a lot. So we will have the backup classes in this, like the chapters which are left. And you both can join the next batch. The next batch which I take there, we are on EM waves. Okay, then
Okay.
everything is completed in a sequence only. It was completed because that is the previous batch. That was the starting batch. So that's why everything is completed and almost we are towards the end of EM waves. So ray optics, from ray optics you can join because in ray optics you don't need much information about electromagnetism.
Okay.
Okay, electromagnetism has not much link with ray optics. If you are starting with ray optics freshly, so you'll be able to relate it, both of you, for Zara and Memuna, both of you. So from in that batch, you will be continuing ray optics. In this, we can then go backward. EMI, then whatever chapters are left, because only current electricity was done. Everything was
Yes.
started very late in this batch, right? So we can properly cover up the syllabus. So like this, you will be prepared for your boards, pre-boards also, and boards also, and everything will be completed on time. That's what I want. So yeah, just see if it's possible, because I think many students do this. Whoever joins late, they the students do this only. Last year also in class 11th also we have done this only. mostly in class 12th this happened, that if anyone joins in this month, then it becomes difficult, because obviously you have lots of syllabus now. Entire second book is there, and you need revision classes also. We have proper revision classes after the completion of syllabus. Proper revision test series goes on, and for your pre-boards you are prepared, then for your boards you are prepared, and proper revision classes are there. So if we do not take the backup right now, if you do not attend extra classes right now, then that time you'll not be able to attend those things. So it's better if you join the extra classes. I'll tell you, there's a time in that. Let me complete EM waves in that batch. Meanwhile, we'll start with EMI in this. I think that's fine to both of you, with both of you.
Yes, ma'am.
Yes, ma'am.
Zara? No.
Yes.
So let us complete this. I just stopped, I think, at this question, no? Did you people write it?
No.
Okay, just write down the question and text me done.
Okay.
At that time only I had to leave. That's why I just stopped in between. Please write class. Your question paper seems fine. Many questions are there directly from NCRT too.
Yes,
And
ma'am.
AC questions, I think AC questions might not be difficult. All these questions we have discussed. See, AC generator, its diagram, that also we have done. EMF part also we had covered that time. Then this device X, you had to see V,
Capacity.
variation of voltage, one cycle is given. Then, okay, the self-induction, I understand, but that's also a formula-based question if you had seen the formula. This LCR circuit we have done, how is this paradox solved? We have seen, I think I discussed this, that we are dealing with phasors. So that's why we cannot just add it or subtract it. Treat it like proper vectors. And this also we discussed. Okay, this diagram we will be discussing in EMI. So, okay, EMI part is fine. Then coefficient of LCR circuit. Paper is not tough. This paper was very easy, but yeah, I understand that EMI was not covered. Let's see, what was the total score? 25? 25?
25. 25.
Okay, question written. Zara,
Yes, ma'am.
Memona, you too?
Yes, ma'am.
Okay. See, it says that the primary coil of an ideal step-up transformer has 100 turns and transformation ratio is 100. So this is very important when you're understanding that transformation ratio is 100. So that is basically NS by NP. I'll tell you this. Input voltage, the input voltage and the power are given 220 volt and 1100 watt. So just do one thing before I start, just write down what all data we have. Like NP for number of turns in primary, like this, just write it. By now, I think you must have written just the data. Solving part I'll do. So yeah, I was saying transformation ratio. See, through the help of transformation ratio, you will be able to write down the question. Basically, NS by NP is equal to the transformation ratio. Now you have the information about NS by NP. You have the information about NP. Yeah. NP is given as 100 turns in the primary. Secondary, we do not know, that we have to calculate too. Input voltage and the power means VP or EP is 220 volt. And power input, this is power input 1100 watt. We just have this information. From this, we have to derive other things. So number of turns in secondary. NS by NP is equal to 100 and NP is 100. So NS is equal to 100 into 100, which is 10 to the power 4 turns. This is the answer for the first part. Second say is voltage across secondary. So NS, NP, EP, all are there. So what did I tell you? That if you are writing NS above, so you have to write ES above by EP. Okay, Zara, please open the camera. So ES we have to find out. EP is 220. So this is 100. This is missing. This is 220. So ES is equal to 220 into 100. Right. So ES is equal to, this is 22 into 10 to the power 3. Okay. Or we can say 2.2 into 10 to the power 4. Both the things are same. Two 2.2 into 10 to the power 4. Okay, this much of voltage. Third part, we have current in the secondary. IS. Okay. And last part is power in the secondary. See, for current in the secondary, we have ESCP. We can calculate it using anything. But the issue is that we do not know the current in the primary. So one thing, you know, P is equal to VI. This formula you must have heard and we have discussed also. So power input is equal to EP into IP. Power input is 1100. This is equal to 220 into IP. From here, we can calculate IP. IP will be equal to 1100 divided by 220. 0 cancelled. 11 into 10. 11 into 2. 5 amperes. Now we can calculate. See, NS by NP is equal to IS by I. P. So this is 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 equal to NS by NP is 100. IP is 5. That's what we have to find out. Current in the secondary, right? So NS by NP is 100. IS by IP. IP we have to find out. So this is straight away IS is equal to 500 amperes. Lastly, power in the power output. Power output will be through ES into IS. Now we have both the things. ES is 2.2 into 10 to the power 4. This is 500. This you can calculate. 500. One thing is there that I told you, for ideal transformation, your percentage should be 100. Percentage of what? Percentage of efficiency should be 100, where the input power is exactly equal to the output power. Okay. So then let's start with Dara, have you also completed?
Yes, ma'am. Not complete.
Okay. So yeah, we had to go in the other order, but now we are following the reverse one. So basically, Unit 4 consists of EMI and AC. AC is your chapter 7, which we have covered, and EMI is your chapter 6. So looking at your paper also, basic questions come. It means the questions that are conducted in the class. If you please revise all those questions, because whatever questions I'm seeing in your paper, all those things are there in this entire document. So for AC also, start revising class. So basically, let's start with EMI. So electromagnetic induction. There was a first concept that when current carrying conductor was present. So there it was observed that yes, when current carrying conductor was present, magnetic field was produced. Right? Magnetic field was produced. Why? Biot-Savart's law. If you look, there's a current carrying conductor and it is producing a magnetic field, right? And vice versa, when you have a magnetic field through a conductor, it produces current. This we already. So both of these things were discovered. Now, why is it produces current or not? This was still a question because this was proved. The first point was proved through the Biot-Savart's law. So you know when a current carrying conductor is present, if a current carrying current conductor is present at point P, I want to find out the magnetic field. I'll get the value of magnetic field. But if I have magnetic field within a conductor, will that be generating current? So that's a tough thing. So the answer was yes, that vice versa also occurs. So, and how this part we have to deal in this chapter. So first thing, that's a very basic thing we have to study is regarding the magnetic flux. Magnetic flux is similar to electric flux. It's just that here in magnetic flux, you talk about the magnetic field lines. In electric flux, you talk about the electric field lines. So suppose I say this is one line which is passing through this plane and making an angle of 90° here. One more is there. One more is there making an angle of 90°. One more is there making an angle of 90° like this. So when we are talking about the flux, magnetic flux, number of field lines which are crossing this area and are perpendicular. So what are these? 1, 2, 3, 4. So straight away the flux is 4. You see number of magnetic field lines which are crossing the area and they have to be perpendicular. So very easy. You can just count the number of field lines. But class, tell me one thing. Here I had drawn 4 field lines. So I was able to calculate the number. Had I taken more number of field lines, would I have been able to calculate? Would I be able to calculate the number of field lines? It's difficult because it was a very easy question and it was visually possible to calculate this 1, 2, 3, 4. This was very easy to calculate. So we had the flux as 4. But when you do not know, when many field lines are there, when you just have the value of electric field and magnetic field, like here we are talking about the magnetic field. If I say just 5 Weber, 5 Tesla of magnetic field is existing. Now tell me the flux. So how will you calculate at that time? So we require a proper formula. That is for sure, that is a need. So the formula is very easy. You take the surface. Now, few things you have to understand. There is always a perpendicular to this plane. This is, we mark this as n cap, and this is called the area vector. This is always taken perpendicular to the surface. Whether your surface is flat like this, you take it like this. Anywhere it is present, you have to take it like this. Okay. So this is what is meant by the magnetic, area vector. Now you might have the electric field in any direction. Oh, sorry, magnetic field in any direction. Let's say this is the magnetic field. So see what areas are possible to be covered. You have this area also. This is the area that the magnetic field is making with the plane. Never consider this area, this angle which is formed. See, this is the plane. This total is 90 degree because this is n cap. This is perpendicular. This angle is also there. Never take this angle from the plane. Always, you have to always take this angle between the magnetic field and the area vector. So theta is the angle between n cap and B, not between B and the plane surface. If you see angle from the plane surface is given, you already know that total is 90 degrees. Subtract it from 90 degree and get this value. But without this value, you will not be able to solve the question. Formula is very easy. When we are talking about the magnetic flux, this is B dot S. Same formula. Where you have V S cos theta, theta is the same. Or if you are integrating also, integral of phi b, this is equal to integral of b dot ds. Same thing. Okay. It's a scalar quantity. SI unit is Webers. SI unit is Webers WP. This is the unit. We have questions on this. We will see questions. First, you write it from the start. Please write it, class. Okay, class, see this question. Magnetic field of 2 Tesla exists in space. It is inclined at 30 degree with the plane. Class, you have to pay attention. What is written with the angle? It is inclined 30 degree with the plane. Means if I have the magnetic field like this angle is 30 degree. Now, in our formula, we know for calculation of magnetic flux, I'm just mentioning B here, and you also have a habit of writing B, because in your exam, when you'll get the question, you will be having on one hand electric flux also and magnetic flux also. So just clarify it, because you can lose marks when mixed up questions are there. So magnetic flux is B dot A, right? Which is B A cos theta. Magnetic field is 2. Area is given 10 meters square. Now cos theta, I cannot take this 30 degree. What did I tell you? We always have to drop a perpendicular end cap. And when you draw this perpendicular end cap, this angle which is formed over here, this is what is the angle of cosine basically. That is a magnetic flux. So here, and this angle is missing over here. So what we should do, we know this is 30 degree, we know the total is 90 degrees. So 90 minus 30, this can tell us that this is 60, and this will be cos 60 degree. So 2 into 10 into half, answer is 10 vapors. Okay, next question, you will try quickly write this and tell me the answers of the next question. These are easy questions, and I think I have noticed these kinds of questions come in your school exam. At least this test, what I have seen, I'll see more papers. If you get more papers, please share it. Keep on updating so that we can also predict. Zara is in the same school, so I think I need not take another paper, right?
Yes, ma'am.
Okay. These kinds of question mean there's a level of question. So this level is good for your school exam. So practice, we do a lot of difficult the questions that came in your exam. We have done a lot of difficult questions more than that. You will see throughout. In AC also, you have noticed we did so much difficult questions, and comparatively better questions came. So if you are unable to get score here in your test, these kinds of tests, so it should be clear that you lack practice. So be prepared with the numericals and all. Please write it and text me so that I can show the next question. Okay, class. See, I'm discussing this. I hope you have tried it. Magnetic field B is equal to 10 I cap plus 3j cap plus k cap. This is in Cartesian form. The previous question which we were doing, that was in the polar form. The magnetic field, sorry, this time I forgot to start the meeting in the focus mode. Now I've started it. So yeah, magnetic field 10 I cap plus 3j cap plus k cap. This is the magnetic field which is existing. Now, flux through an area of 2 meters square. Now see, when you have the Cartesian form मतलब I cap, J cap, K cap के terms में. Polar form मतलब angle के terms में. So when we are talking about the magnetic flux here, this is magnetic field dot A. Magnetic field is 10 I cap plus 3 J cap plus K cap. Now, how can I multiply this with just 2 meters square? This is not even matching. I cannot just multiply it. I need it also in Cartesian form. How to get it? Best thing is that, what is YZ plane? YZ plane means, see, this is X, Y plane. This is the Z axis. So this plane is the YZ plane. So like this, the sheet is situated. Okay. Now I have to use the n cap as the area vector. If I drop n cap, in which direction is it going? Which unit vector?
Going in the direction of X.
I cap. It is going in I cap. See, this is positive x axis. This is I cap. So this is 2 I cap. Now you know how to solve it. Rest of it will be 0. See, 2 into 20, 10 is 20. 3 into 0, 1 into 0. Directly this is 20 Weber. This is it. Okay. Write it. let us start with Faraday's experiment. So basically, this Faraday's experiment involves there was a coil loop which was taken. These experiments are very easy. Actually, you have to remember the conclusion, which is very important. So basically, there was just a loop and a galvanometer was attached. So these arrows are showing that if the current is flowing in the circuit, the deflection will be produced, because you know that galvanometer has one single function, that is to determine the current in your circuit. So in your circuit, if you have the current, the galvanometer shows a deflection. If the current is very less in your circuit, it shows a slight deflection. And if it is greater in your, if the current is greater in your circuit, then it shows a better deflection. Slighter deflection or better deflection, that's the difference. But the deflection is only given. For the calculation or measurement of current, you already have a device which is ammeter. So these things are left that we'll cover in these classes in your magnetism chapter. So see, so this loop is present, and within this loop, what did Faraday do? In his first experiment, he just took a bar magnet and he brought the bar magnet towards the coil. So he observed that magnetic field was there because of the coil. And when with v velocity, the magnetic, see, it's like the coil is present. This is the coil. And a bar magnet, like this, a bar magnet is being brought. So what is happening? He noticed that there's a deflection which is observed. So if a deflection is observed, it means a current is there in your circuit, and a current without any other source except for magnet indicates that magnetic field is also responsible for the production of current. Like the current is responsible for the production of magnetic field in few cases, in current carrying conductors, which we have seen in your Biot-Savart's law, especially you have seen there. Vice versa also is true. That is when the bar magnet, that is the magnetic field lines, if they are brought, they can also reproduce current. So that was the first thing through his experiment. That's why I was saying that the reverse is also possible. Answer was yes through Faraday's experiments. Secondly, he noticed that again, when the bar magnet was brought away from the coil, still in lesser amount, the magnetic field lines were produced, which led the current produced in the circuit, and there was a deflection indicating current. Observed when the bar magnet was not moved at all, it wasn't brought closer to the coil, current was also zero because there was no deflection observed. So this confirmed the third experiment. This confirms that yes, only the bar magnet which was coming closer to the coil was responsible for the production of the current. Because when this bar magnet was brought closer, then only these phenomena were occurring. But when this bar magnet was stopped, it was at rest, then it was noticed that nothing was happening. It means the only source is the magnetic field, because you don't have a battery, you don't have a cell. How will the current be produced? By just connecting a wire and a galvanometer. What is this coil? Coil is just a galvanometer. So this also proved that yes, vice versa also happens. That was his first experiment. In his second experiment, what did he do? Instead of just having the bar magnet move, bar magnet was stationary. Now this time the coil moved. So current was also induced that time, because it was coming closer to bar magnet. It was coming the coil was coming closer to the electric field, to the magnetic field, because of which current was produced. So this is also a confirmatory experiment. Third one is there, which we have already studied in AC, the entire setup of induction and everything. So a rod, copper windings were connected to iron rod, and a galvanometer was connected to a rheostat battery, and the entire circuit was set up. So this was regarding AC, alternating current was produced. So this is a part of AC, you can ignore it. But what all these things are leading us to a conclusion? All these things are leading to a conclusion that when the magnetic field, that whenever the magnetic flux linked with the closed circuit changes, see, when it was brought closer, magnetic field lines were increasing. If magnetic field lines are increasing, magnetic flux will increase. Because you know, in the formula, magnetic flux is related to magnetic field only, because magnetic field is existing. So you are having magnetic flux in your circuit. So if there is a change in the magnetic flux, we had seen when the coil was moving, when the bar magnet was taken away, when the bar magnet was brought together. So it was observed whenever the magnetic flux changed, there was current produced. There was induced EMF. So an induced EMF, so what did the law say? Let's read it. Whenever the magnetic flux linked with the closed circuit changes, an induced EMF and hence an induced current is set up in it. Okay, there is the production. This is the first law, that yes, current induced and EMF is induced whenever there is a change in the flux. Change in flux means flux can increase or flux can decrease. Why this is happening? Because the magnetic field can increase and decrease. That is the first point. Secondly, okay, these two things have come into action. Current is also induced, EMF is also induced. Now, how do we get to know about this induced EMF? We cannot stop the story here. Okay, he did so much, he just concluded this fact. But as a student, if you have to calculate EMF, if you want to find out further, so you should have some information about induced EMF too. So induced EMF, the second law basically, it says that the higher the rate of magnetic flux within closed circuit, greater is the induced EMF. It means what? If the EMF is greater, if the magnetic flux is greater, EMF is greater. It means when it is lower, this is lower. So what is this indicating? That they are directly proportional. Induced EMF, this is directly proportional to the magnetic flux's rate. Means within a span, within a time, how much flux is changing. That is the rate of magnetic flux. Okay. Rate of magnetic flux. Rate means anything which is changing with respect to time. You must have used it in your class 11th. You must have used the term rate of change of velocity is acceleration. Rate of change of displacement is velocity, right? You have used these terms in your class 11th.
Yes, ma'am.
Okay, so you are aware about this. So why did we use the term rate? Because anything that is changing with respect to time is called rate. So similarly, it was noticed that within this time, whatever magnetic flux was changing with respect to time, it was proportional to induced current, EMF. Because when this is increasing, this is increasing. When this is decreasing, this is decreasing, same as it is. So what are the laws of EMI? What laws are exactly? This I'll discuss in later, but till here it is very important. I'm repeating. In his first experiment, when the bar magnet was brought closer to the coil, magnetic fields were changing. Why? What is happening? Magnetic field is increasing this time. So flux is increasing because it is brought closer. So current is produced. In the second case, the bar magnet is taken away. So flux is decreasing. Why? Because magnetic field is decreasing. Still current is produced in the circuit. But in the third one, nothing was produced. Second experiment said that when the coil also moved with this V velocity, you had the current, induced current and induced potential were present. Third is regarding AC. And so what we can conclude that whenever this magnetic field changes or magnetic flux changes, induced EMF is present, induced current is present. And the induced EMF is directly proportional to rate of change of magnetic flux. Tell me, Mamuna, everything is clear till here?
Yes, ma'am.
Okay, good then. Start writing, please.